Welcome back to Paris AB conference. So we'll start with Kirk Haines. So thank you, Kirk, for being here.
Thank you.
And let's go.
All right. So this is going to be fun because when I originally wrote this talk, it was a 40-minute talk. And so every time I've tried to give it in under 20 minutes, it's come out a little bit different. So it's just an adventure, and we'll see what happens. If there's some slide that I fly right over and you have questions about it, either ask me at the end or come find me, because there's some things I'm just going to fly through really quickly. So it's Rubies all the way down. What I'm really talking about here is both kind of a historical look at how the modern Ruby web stack developed the way it did, and also looking at some ways that in my own practice writing Ruby web apps, I sort of pushed the boundaries of some of these areas that weren't typically done with Ruby, and how that worked out. So I started doing Ruby in 2001, and I did my first professional Ruby web app in 2002. And in that time, I've done oodles and oodles of sites and apps and multiple server implementations. I currently work for CookPad. And so let's just dive right into it. And let me start my timer so that I have some idea of how far behind I am. So what is a stack? When I'm talking about a stack, I'm really talking about all of the components that go into allowing your web application to do whatever it is that it needs to do. And in a modern web application, there's usually a whole bunch of layers. And these layers that I have up here are kind of the distillation of what you typically find in a web app. You know, some might have a few more, some might have a few less, but this is pretty typical. Now, of these, there's only a few that are ever really done in Ruby. I mean, obviously, you're writing your web application itself in Ruby. You may be deploying with Capistrano, which is Ruby software. Some of you may have used FluentD for managing your logs for your entire application. And you may be using Chef or maybe Itamea for your configuration management. But most of those other layers, Ruby never touches them. You know, you use Varnish, you use Nginx, you use HAProxy, you use things like that for those other layers. So stepping back a little bit to the beginning, when I started with Ruby, I started in Ruby 1.6.6. And I came to it from Perl. And at that time in Perl, there was a lot of things for doing web development. When I came to Ruby, I skipped ahead a little bit there. But when I came to Ruby, I really loved Ruby, and I wanted to use Ruby for my next web development gig. And so I got one in 2002. I was supposed to write a job search application for college interns. And so I said, all right, let's do it. And what I found is that there were no real frameworks for web development in Ruby then, and there were very, very few tools. Some basic templating with something called Amrita, and other than that, you were pretty much on your own. You could use raw CGI, or you could use something called ModRuby, which let you embed your Ruby interpreter inside Apache. This was even before ERB existed. And so the Ruby stack as it existed then, there wasn't much of a stack to it. It was CGI scripts, or you stuck your stuff inside Apache, but it was still essentially CGI scripts living in Apache. Now, when I started looking around to see what my options were, I came across this thing called Iowa. And Iowa was a proof of concept that was written by a guy by the name of Avi Bryant. And he went on to take those ideas that he prototyped with Ruby, and he took them to Smalltalk and implemented the Seaside framework. And so when I found Iowa, it was abandonware, and it wasn't really suitable for production. But I hacked on it, and I turned it into something that I could use. And that first web app that I developed, I released on Iowa. And the stack that I had at that time looked a little bit modernish in the sense that you had multiple processes that were sitting out here, and they were talking via a socket back to the web server, which happened to be Apache. So fast forward a couple years, and Rails hit the Ruby world. And Rails sort of transformed everything. The marketing behind it generated so much excitement. Everybody adopted Rails, and everybody loved Rails. Rails was still very Apache-centric in how it was deployed. And it used something called FCGI, which let the various processes run externally and communicate back with the web server via a socket. But FCGI had some serious scaling issues. It caused a lot of stress for people trying to figure out how to manage their production applications, how to scale their production applications with FCGI. But the Rails world continued to run on FCGI and some variations for a couple of years. A couple of years later, this thing called Mongrel showed up. Zed Shah sent an email saying, hey, I wrote this web server. It's pretty fast. Why don't you take a look? And it was written mostly in Ruby. This HTTP parser is written in C, but everything else is in Ruby. And it was fast. It was really fast. And it was almost overnight, it became adopted as the preferred way to deploy your Rails applications. And so at that point in time, sort of the Ruby web stack as a whole was starting to evolve. And you saw adoption of other web servers like Nginx. And over time, things shifted away from Apache and primarily towards Nginx in the Ruby world. Now, back in my own little isolated world where I was sitting there writing tons and tons of apps for years, I never adopted Rails because Rails was a slow, resource-intensive pig, and it wouldn't work for what I did economically at the time. It was too resource-intensive. So I never adopted it for what I was doing, and I've stuck with Iowa because it was fast and light for my things. And I had developed a whole bunch of different ways of deploying my Iowa apps. And so along the way, I had developed something that wasn't Rack, but had the same goals as Rack, to be agnostic in that way. And some of that original code ended up getting pulled into the original Rack, which came about in 2007. And Rack really gave the Rails world an agnostic way to interface between web servers or between middlewares and your applications. So you could have things on the left and things on the right, and they could talk to each other without having a lot of low-level, the developer have to worry about all the low-level details of getting those to interface. And that really opened up a lot of avenues in Ruby web stacks. So back again over on my side, one of the things about Iowa that I really loved is that it did some magic with regard to state management and with regard to getting your information from the web browser into your application to your web browser. It just handled a lot of stuff so that you didn't have to worry about what was in your form and what variables and how you called it and how you got it into your web app. It just did it all automatically, and it ended up in instance variables and objects in your code. But one of the downsides to the way that it was implemented is that all of that session state was stored in a single process. And so once you started a session, any request for that session subsequently had to be routed to the same process on the same machine. And there wasn't any good way to do this in the 2007, 2008 timeframe. There wasn't anything that really worked. The HA proxy sticky session support just wouldn't cut it back then. And so I thought, let's write it in Ruby. What could go wrong? And so when I started talking to some other people about it, the feedback I got was, you can't do that in Ruby. Ruby's too slow. I mean, Ruby 1.8, it's slow. You need to write it in something else. But I sort of ignored that and persisted. And it wasn't slow. These timings that I did here, I did on a DigitalOcean instance about a month ago. Cheap $10 instance running 251. Because I didn't have recorded anywhere some of the benchmarks that I did back when I originally did it. Otherwise, I would have thrown them up there. But back then, I was running about 15,000 requests a second on commodity 2008 hardware. It was, for what it did, it was as fast as Nginx. Now, it didn't do nearly as much stuff as Nginx, but for what it did, it was as fast as Nginx. And that sort of was an epiphany for me at that time, because it said, you can write stuff in Ruby that can be fast as long as you target what you're doing to what you need to do, and you don't do more than you need to do. It can be fast. Now, Rack got support for Swift Apply around version 0.9, and from that point forward, I had one simple all Ruby stack top to bottom that could be used for both for my I/O apps and for the Rails apps that I was handling. And so this is kind of what my stack looked like around 2009. Now, there's a thing in there, Logger, that I haven't mentioned yet. One of the things that I ran into, by this time I had like 100 production web apps out in the world. And managing all the log files for those when they were distributed over multiple machines, multiple processes, it was a nightmare. If there was a bug in something, it's like, okay, which of 7 machines is the log going to show up on that has the bug? And so I wanted a way to take all those logs, pull them all together, and have them in some format that I could deal with them all together. And I thought, well, why don't I write this in Ruby too? And so my goals were that it needed to be fast. It needed to be fast enough that it didn't matter whether I put one logging statement in something or 100, my web app performance wouldn't be noticeably impacted by it. Needed to be API compatible with the Ruby logger, and I didn't care if I lost a few messages if the logging process went down. The main things were that I got most of them because the server's not going to go down that often. And so, again, Ruby came through. These timings were also done on a modern server versus one of the old ones. But basically, using Ruby, I'm not CPU bound at all, I'm IO bound. I can log absolutely as many messages as my disk can write, as my network can transmit. And in that, Ruby 186, 187 time frame, it was about 60% the speed. So even back then, it was quite fast. It was more than fast enough for my design goals. And this basic architecture is still running today. There's a number of mutual fund and financial websites that are out in the world running on this, and nobody knows. There's a major US bank that runs a key portion of their legal workflow for dealing with clients. They run an application on this architecture. And it's been running for 7 years now on this architecture. Nobody knows, it just runs. It's completely ignored for the most part, and it just runs. So then the question sort of became, what other areas of this stack that aren't normally touched with Ruby can you actually touch with Ruby and do a reasonable job of it? And so I'm just going to hit on a few of those here in the last few minutes of this talk, just to kind of expose some other things that are possible. Now, there's a library that's been around for Ruby called emproxy, and it's been around for quite a few years. I forget when it came out. It seems like it was around 2011 as well. It uses Event Machine for the underlying network layer. And Event Machine, if you aren't familiar with it, is a event-based networking library for Ruby. Writing event-based code is kind of mind-bending because you have to deal with callbacks and your control flow gets kind of confusing. But emproxy, as a DSL, wraps all that up in a way that it becomes transparent. And it allows you to write really fast proxies in a relatively small amount of code. And this link that I have here, it's a full HTTP proxy. It has multiple different strategies, and it's in 200 lines of code. And it's pretty readable. I mean, this little section is just like the core of it, but it's nice, easy, readable code written in Ruby, and it's fast. I mean, it's blazingly fast. And another area that's often ignored with Ruby is WebBrick. There's a lot of functionality bundled in WebBrick, and people tend to just ignore it. WebBrick actually bundles a full HTTP proxy implementation. It's beyond the scope of the time that I have here, but you can put together a full proxy in a few lines of code using WebBrick, and that link has an article that shows how one guy did it. Now, another area you'd never think of using Ruby for this is asset caching, and this is something like Varnish. You have a request that comes in, and if you've never seen this request before, it doesn't meet certain criteria, you send it off into your server farm and it gets handled. If it does meet certain criteria and you've seen it before and you have some stored content, you just return the content, and that way the request doesn't go on down the chain to your Rails app. So it's basically just a proxy with some added intelligence. And I got to thinking, okay, Puma's pretty fast. We've got Rack. Rack makes it easy to spin up all kinds of crazy stuff. So can we write something in Ruby that's reasonably performant and does the job, just using these off-the-shelf components? And so I threw together this thing called shellac. And this is it's actually running. If you go to parisrb2008.demos4.us, it's actually running there right now. And so you can, what it's set up to do right there in that command line is it's proxying to GitHub. And so, like if you do that URL that I have in there, it will proxy you back my page on GitHub. And it's reasonably fast. It's running on a $5 DigitalOcean instance, and it'll proxy, up to 1,800 requests a second. It's pretty fast off of a little piece of Ruby that I slapped together with some off-the-shelf components. Now, it's also not production ready by any means because it was put together specifically for this talk that I gave 3 weeks ago. And this talk, there's a lot of things that would need to go into it to really make it safe for production use. But it proves the point. It doesn't take a lot of code, doesn't take a lot of work, and you can get something that performs pretty well out of Ruby today for a job that is not typically thought of as a Ruby job. Now, another example for that is just a simple web server for serving static assets. Now, I threw this up here just because I find it hilarious. It's an HTTP 0.9 compliant web server, more or less, written with a little bit of shell and a little bit of Ruby, and it's really horrible, and don't ever do this, but it basically works. Now, for an actual web server, again, you've got WebBrick. WebBrick is quite performant. 2,700 requests a second on a DigitalOcean instance. This was returning, I think, the README. It was returning a README out of something. I forget what I was pulling. Now, you can do the same thing with Puma with just a few lines of code. And Puma's faster than WebBrick, but Puma's not actually a lot faster than WebBrick for things like this. On that same instance, Puma returned about 3,000 requests a second. And on that same instance, Nginx returned about 4,500. So clearly, Nginx has a performance, superior performance to Puma, but it's not like an order of magnitude different. It's 3,000 versus 4,500. Ruby can acquit itself pretty well for a few lines of code plus a generic web server package. Now, one area that I haven't found that there is any Ruby implementations that have ever been done is an actual database. That I found nobody's actually tried to implement a database in Ruby. Now, I'm playing with kind of a crazy idea to combine Ruby plus SQLite plus a gossip protocol to create a distributed SQL database. We'll see if it pans out or not, but nobody else has tried anything like this, so it's kind of a fun experiment. One area, though, that has been done and works pretty well is a key value store in Ruby. There's something called Roma, and Roma was written by Rakuten, big Japanese company. And it's a Memcache-compatible key value store. It doesn't have a lot of code. You can look at it and pretty easily understand what it's doing. And these timings here were done off of 3 $5 cheap nodes. And it's not blazingly fast, but I was ensuring that all the data was written to at least 2 nodes and it was written persistently. And so again, a lot of that timing is both the DigitalOcean network timing and the I/O overhead to write those out. Rakuten claims a performance of over 10,000 queries a second if you're using just in-memory data stores like Memcache would do on AWS data. And this was off of 2015 slides that they were claiming this. So it's quite performant, and it's all Ruby. You can easily hook into it to modify it, to have different storage backends or things like that. It's really accessible code, and it's fast. Now, one other thing that I did that I'm going to just sort of blaze through quickly, but for deployments, there's Capistrano, and I bet a lot of you have used Capistrano. Capistrano is written in Ruby. I like using Git. And when I am working on something, I like to be able to do a Git push or a merge into some specific branch and just automatically have that branch get deployed out. I'm running out of time, aren't I? I wanted to see if I could throw this together in Ruby. And so what I did, and I'm just going to blaze through this. You can use Git with remotes to do this, but it isn't quite ideal. So I built off of something called Surf, which basically lets you send messages to multiple machines in your cluster and get invoke commands. And one of the things that it does is it allows you to hook handlers into it. And so I created a little DSL to write Ruby handlers for Surf. And it's a simple DSL. You just describe what it's doing, and you have a block that has the action. And by slaving that with this other thing that I wrote called Git index, which just creates a database of Git repositories on your system with fingerprints, basically it's the hashes. You can combine the two of them to do a Git push from your machine, and it'll go out to however many servers you have in your cluster and do the deploy automatically. All in a relatively few lines of Git. The only thing that I'm going to mention, because I'm basically out of time, is that there's some other stuff like this file sync that was done for a magazine article. It's a few hundred lines of Ruby, and it does a distributed file sync with Ruby. It's pretty slick, and it doesn't take much to do it. So just kind of to wrap up, there's all kinds of things that you can actually do with Ruby code that people most of the time don't think they can do because they think, oh, it's going to be too slow. Or, Ruby's not going to be able to perform doing that. But a lot of times, if you focus your development on just the things that you need, Ruby can come through and can really perform for you. And I've had, like I said, I've had a version of this stack running for 7 years on some high-end production web applications. So, anybody have any questions?
So we have like 3 minutes for questions, so be fast. Anybody?
Okay.
Okay.
Thank you.